Psst, IEB grade 12s, step closer. We're about to get exam ready. Alright guys, let's get exam ready with last year's IEB final physics paper. We're going to start with question 2. Please stay tuned, make sure to follow and subscribe. And I'm going to show you in a separate video how to tackle multiple choice questions. You don't want to miss that one. Alright, question 2 then says, the velocity time graph below represents the motion of a trolley on a surface during a 12-second time period. We see this graph that's been given to us there. Over 12 seconds it goes up, stays constant, and then comes down to zero velocity, right? 2.1 says, define acceleration. Again, definitions are a nice low-hanging fruit. Make sure you learn your definitions. There's a lot of marks that you can get from that. So the definition of acceleration is as follows. Acceleration is the rate of change of velocity. Super simple, super easy. That's how you get the 2 marks for that question. Let's jump on to 2.2. 2.2 then says, determine the magnitude of the acceleration of the trolley during the first 4 seconds shown. All right, let's go back, then we can see that. So for the first 4 seconds, we can see that our velocity starts at 0.4 meters per second and increases linearly up until 0.9 meters per second. We need to find the acceleration. Now remember, to find the acceleration from a VT graph, we find the gradient of that part of the graph. So if we can find the gradient for this part of the graph here, that will give us the acceleration, and then we can jump in and get our answer. Super simple, super easy. Let's work that out quickly together. So as we see there, our acceleration is going to be equal to the gradient, right, which is going to be our change in y over our change in x. Let's substitute our values, y final minus y initial. That's 0.9 minus 0.4 divided by delta x, right? X final minus x initial, that's going to be 4 minus 0. You can simply pop that into your calculator, and you should get an answer of 0.125 meters per second. And again, they asked for the magnitude. I don't need to put a direction for that acceleration there. 3 super easy marks, guys. You guys really can do this. Let's jump on to 2.3. 2.3 then says, calculate the magnitude of the displacement of the trolley from 0 to 4 seconds. Now remember, we said with a VT graph, acceleration is the gradient, right? Quickly comment down if you know how to then work out the displacement from a VT graph. I'll give you guys 3 seconds. 3, 2, 1. That's correct. So to get the displacement from a VT graph, we need to find the area under the curve or under the graph for the first 4 seconds. And to work out that area, super simple, we just find the 2 shapes. So there's a triangle there and there's a square or rectangle underneath. And then we simply add those 2 areas together to get the displacement. Let's jump in. So to find the displacement, in that case there, our S equals the area under the curve, right? Which means we need the area of our triangle plus the area of our rectangle. That's going to be half base times height plus simply another base times height, or length times breadth, however you want to look at it. Let's find the values of what we're dealing with there. For our triangle there, so we've got a base of 4 and a height of 0.9 minus 0.4, which is 0.5. So we'll then have a base of 4 and a height of 0.5. Let's plug those values in there. So we'll have here half, our base was 4, right, which will be 4, and our height was 0.5, plus then the rectangle or the square that we're looking at there, a base of 4 and a height of 0.4. Let's quickly put that in there. That's a base of 4 and a height of 0.4. You can simply pop all of that into your calculator, and you should get an answer there of 2.6 meters. And again, we're looking at magnitude, right? So displacement is a vector, but magnitude only has, it has no direction. So we can leave it as 2.6 meters. Super easy, nothing challenging, guys. Let's jump straight onto 2.4. 2.4 then says, state Newton's second law of motion in words. That's chilled, nothing hectic. If we look at that there, we can see that it says, when a net force acts on an object the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Two very easy marks. If you are like me and you don't do very well with memorizing long pieces of text, let me give you a quick little shortcut, right? So think about Newton's second law. What is the equation? The equation for Newton's second law is F net is equal to m times a. Now, all you have to do is try your best to take that equation and say it in words, right? And then you're going to say what the equation says, and then you can also then talk about the proportionality of it. Start in the beginning. So when a net force acts on an object, so the object is the mass, right? The object will accelerate in the direction of the object. Perfect. We've got our first mark out of 2. F net is equal to ma. When a net force is acting on an object, the m, that object will accelerate, the a. Then I start at the end and work my way back. So the acceleration will be directly proportional to my net force, yet inversely proportional to the mass of the object. Super easy, right? That's 2 very free marks. Let's jump on to 2.5. 2.5 then says, on the axes given below, sketch a graph of the net force acting on the trolley over the 12-second period. No values need to be shown. Okay, let's first go look at what is happening in our graph. So we can see for the first 4 seconds here, right, we have a positive gradient. Remember, the gradient of a VT graph gives us my acceleration. So that means my acceleration for the first 4 seconds must be positive, meaning above the x-axis. We were told we don't need to give specific values, right? Next up, we can see from second 4 to second 10, my velocity does not change. It's constant velocity. What does that mean about my acceleration? I've got 0 acceleration, right? Okay. Finally, for the last 2 seconds there, you can see from 10 to 12, I drop all the way down to 0. And then what I want you guys to tell me quickly in the comments, is the acceleration from 10 to 12 greater than, less than, or equal to the acceleration from 0 to 4? Just talking about magnitude. Is it a bigger number or a smaller number? I'll give you 5 seconds to quickly post your answers in the comment. 5, 4, 3, 2, 1, exactly, right? The acceleration here will be higher in magnitude. The difference is that it's going to be negative. So when you draw it in your graph, you'll put it on the negative side of my graph, but it must have a greater magnitude than the first 4 seconds. And now with all of that, let's simply go plug it in and draw it in our graph. Very easy question there. So for the first 4 seconds, we can pick the value arbitrarily. They said we don't have to show values. So I'll just draw a straight line that goes from there to there. Super chilled, nothing hectic. Then we know from second 4 all the way to second 10, I've got constant velocity, 0 acceleration, right? So I'll draw my dotted line coming down to 4. Then from 4 to 10, I will then have my straight line there. That's going to be on my x-axis. Then from 10 to 12, I've got negative acceleration. But what's very important is that I have to show that my acceleration from 10 to 12 is greater in magnitude than the acceleration from 0 to 4. So it must just be the gap from here to there must be bigger, smaller than this gap here. So this gap must be bigger for the second part. So I'll just draw my dotted line coming this way, and then I'll put my line in there. Perfect. And that's what we've got there in terms of our force versus time graph. Nothing crazy. 4, I think, free marks. Okay, let's jump on to 2.6. 2.6 says, the magnitude of the net force on the trolley between 10 seconds and 12 seconds is 0.18 newtons. Determine the mass of the trolley. So we have to find the mass of the trolley given the magnitude of the force. So we're dealing with a force, we're dealing with a mass. What equation are we going to need to use here? Quickly post in the chat what you think the equation we need to use is. I'll give you guys 5 seconds. 5, 4, 3, 2, 1, exactly. F net is equal to ma, right? And let's see how we solve this particularly. So we can jump in here and then say F net is equal to m times a. We were given the net force right there, 0.18, so we've got that. The mass of the trolley is what we're trying to solve, so that's we're going to leave there as our unknown. And then the acceleration, right, is something that we can work out. The same way we worked out acceleration for the first part of our graph, this part here, we'll work out the acceleration for the last part of our graph, that 10 to 12 seconds, simply by finding the gradient of my curve. So let's quickly jump into that question and solve it. I'm first going to expand out my formula so I can leave it in a point where I can just jump in and substitute everything. So let me just rewrite this. F net is equal to mass times my acceleration, and my acceleration in this case here is going to be the gradient of said curve, right? So final minus initial, my final value for my velocity was 0, as you can see here. The initial value is 0,9, and the difference, my delta x, will be 12 minus 10, which will be 2, right? So let's quickly put that in there. So it'll be my VF minus my VI, and then divided by my delta t at the bottom there. That's my acceleration. Now I can substitute values and solve for the mass. So the F net, right, was given to us as 0.18. But again, remember, we're dealing with vectors here. So we have to then decide, is this going to be a positive 0,18 or a negative 0,18? And because we can see on our graph here that we have a negative gradient, we have to substitute a negative 0,18. Otherwise, you're going to end up with incorrect values, right? So let's sub the values in there. That's a negative 0,18. That's equal to the mass, which we're trying to solve for. And then you have to multiply that by the final velocity was 0, the minus my initial velocity was 0,9, divided by delta t, which is 12 minus 10, which is simply 2. And then I can take this and then make m the subject of the formula and then solve for m. So in this case here, m is going to basically be equal to a negative 0,18 times 2 divided by negative 0,9, right? Take that, substitute it into your calculator, and what you should find, you should get an answer of 0,4 kilograms. Mass is a scalar, doesn't have a direction, but that's super easy, nothing too hectic. Fantastic, guys. Please join us on our YouTube page to watch the full solution for this whole paper. Otherwise, just follow us, and we should be posting a part 2 very soon. See you guys next time. Cheers. Wait. Before you leave, we have workshops coming up from the 18th of October. You're not going to miss this. You're going to get phenomenal teaching from really good educators. We're going to help you guys solve exam problems, show you guys how to really understand what's being requested of you, and will help you guys get really confident and comfortable with solving exam type problems. Go to thelearningspace.co.za, click on workshops at the top, and book now. I mean, you can join us online from as little as 250 Rand, or in person if you're based in Johannesburg or Bryanston for 500 Rand per day. That's for the entire day, not per hour, for the entire day. Even online, the 250, it's for the entire day. So we can't wait to see you guys there. I'll be one of your presenters. You've seen all our other amazing educators. They'll be there as well. See you guys. Be there or be square.